Selecting units is one of the core features of any RTS game, and doing that is easier than you might think. So, let's see how we can do that. Here's our scene. We have our basic bot unit that can move around. It doesn't need much. It has a simple script that can move it, and a hidden selection mesh that indicates when it is selected. And we also need to add it to a group. So select the root, go to the Node tab, and select the Groups tab. Then click on the plus sign to add a new group. We'll create a group named Units, and set it to global. And you can also add a description here, so you can remember what the group was later. Now the node will have a group icon to indicate it belongs to a group. Groups is a very useful tool in Godot. It allows you to quickly get a reference of all the objects that belong to that group. Back to our scene, let's create a new node for our mouse selection script and name it Mouse Selection. And let's also add a color rect UI node. This is what our selection box is going to look like when we are dragging the mouse. So let's set the color to a light blue and add some transparency. Don't worry about its position and size. We are going to be controlling that from code. And let's also add a mesh to display where the target position is when moving units. I'm going to use this flag mesh and put it inside the mouse selection node. Make sure it is not visible and rename it to target, and I'll give it a unique name to access it from the code. Let's also rename the color rect to selection rect and give it a unique name as well. And to make our lives easier, go to project settings and create a new input map for the click and right click actions. Click on the plus sign and left click on the box that says listening to input. And do the same for the right mouse button input, but right clicking this time. Now we can finally start working on our script. So let's create a new script to our mouse selection node. Let's start by drawing the selection box. First, we save references for the selection box in the target flag mesh. We also need a mouse dragging variable to indicate if we are holding the mouse, and a drag start position to tell where the mouse click started, and a list of all the units we have selected that we'll use later. On the input function, we check if the click action is pressed. If it is, we set mouse dragging to true and save the mouse position with event.position. Then we set our selection box to visible with selectionRect.show and set its position to the mouse point and the size to 0 for now. And when we release the click, we reset the mouse dragging variable and hide the selection box again. Then we are going to check if we are dragging the mouse and the event is of the type input event mouse motion. This is the event that appears when the mouse has moved, and it gives us the velocity, displacement, and position of the mouse. To update the selection gizmo, we will need to calculate the size of the rect. So we set the mouse start to be where the mouse position was when the click started, and the mouse end to be the event.position, where the mouse currently is. Then we calculate the difference by taking the mouse end position minus the click start position, and we take that and create a new rect2 class, using the mstart for the position and the diff variable for its size, and calling its absolute function. This will make sure the size is not negative, and it will fix the position and size if it is. This is important to be able to calculate the collisions later. Now we just need to set the color rect selection rect to be the same as this rect for now. And let's not forget to also hide the selection box node. And just like that, we can click and drag our selection box, which works in any direction. Now to actually select the units, we are going to use a very interesting technique. So we are going to create two new functions. A clear selected units that deselect all units that we are going to call when the start click action begins, and a select units to be projected that will actually select the units when we update the gizmo. The clear selected units just iterates over all the selected units and set their selected status to false before clearing the list. It is important to always check for the isInstance valid here. This will prevent a crash if the unit has already been destroyed elsewhere. I'm using the selected variable here that also hides the selection mesh of the unit, but you can use your own logic to handle how the selection works. For example, you can show the health bar, play sounds, or anything else. And then we have the select units function that receives the selection rect. The way this works is very interesting. We can check if a unit is inside a 2D selection box by taking the unit's position in 3D space and converting it into the 2D screen plane. First we take all the selected units by calling get3.getNodesInGroups units. Then we get a reference for the camera with getViewport.getCamera3D. And then we iterate each unit to see if it is inside the rect. You can use the rect.hasPoint function to see if the 2D point is inside the rect. And we use the camera.unprojectPosition to turn our unit's global 3D position into a 2D position on the screen. If the unit is inside the selection box, we just need to make sure it is not already selected and then select it, and add it to the selected units list. I'm using the unit selected variable here to check for that. And now we can finally select our unit. But let's add a few more to our scene, so let me just select our bot and duplicate it a few times. And yeah, it still works. Now let's make them move. To make the units move, we are going to check for event.isActionPressed, right-click. Then we are going to use a raycast from the camera until it hits the ground by calling mouse screen to world, giving it a camera and the collision layer to check for it. The one here is the default layer all objects start with. And if our ray has hit something, we set the target global position to be the ray's hit position. Show the target flag and set the move target to all units within our selected units list. Our raycast code itself looks a bit more complicated, but we can get everything we need from the camera. We take the mouse position with the getRayPort.getMousePosition, the ray origin with the camera.projectRayOrigin of the mouse position, and the ray end position with the ray origin plus the project ray normal, and multiply that by a large value to set our max hit distance. To execute the raycast itself, we need a physics space state that we can get from getWord3D.directSpaceState. And to call the raycast, we need to create a physics carry parameter 3D, where we set where it starts, where it ends, and what to hit. And finally, we call spacestate.intersectRay, passing our carry parameters. And this will give us a dictionary with the collision results that we return. Now everything seems to be working, and we can move our bots around. But we can't select units by just clicking on them, only when the drag starts. So let's fix that. To fix that is very simple. Back to our click release code, we now check if we have no selected units, and if that is true, we execute a raycast from the mouse and see if it hits any character body 3D, or whatever your unit class is. You can also use a specific collision layer for your units and make sure you are only checking the raycast for that. But if it hits a unit, we change its status to selected and push it to the selected units list. And now that's fixed, we can now not only select multiple units, but also single units with a click. And just in case you are wondering, you can display the Navmesh agent debug lines by going to the Unit Navigation Agent 3D and enable it under the debug category. But that's it. As always, you can check the code on Patreon if you want to support me. Now you can select your units and start making your very own RTS game. I hope you liked this video, and until next time.